So, alright, welcome to this video. In this video, we are going to look at reflection of light at plane surface. We now have some subtopics under this. It means what we are going to be discussing in general are the first one. We'll look at what now? Definition of reflection. Definition of reflection. Definition of reflection. That's the first thing. After this, we'll discuss types of reflection. Types of reflection. Types of reflection. After this, we'll discuss the geometry of plane mirror. Geometry of plane mirror. After this, we'll discuss the laws of reflection. Laws of reflection. Then we look at what we call rotation of a mirror. Rotation of a mirror. The after the mirror, we discuss number of images. Number of images formed by inclined mirrors. Inclined mirrors. Inclined mirrors. After this, we discuss total angle of deviation. Total angle of deviation. Total angle of deviation between inclined mirrors. Between inclined mirrors. Inclined mirrors. Then the last we discuss characteristics of images. Characteristics of images. Is it okay like this? Characteristics of images. Characteristics of images formed by plane mirror. Plane mirror, and we now discuss uses of plane mirror. Plane mirror. So these are what we shall be discussing under this word now. Reflection of light at plane surface is. I will invite us to watch the video from the beginning to the end so that you not miss out on all these what now listed subtopics under reflection of light at plane surface. So without wasting our time, let us go to the first one, which is what now? Definition of reflection. Reflection is just the bouncing back of light when it strikes or it hits a surface. So we define reflection as the bouncing back of light when it strikes a surface. Okay, when it strikes a surface, that's what we call reflection. Okay, so this surface now can either be smooth or rough. Are you with me now? So when the thing strikes what now? A smooth surface, we call it regular reflection. And when it strikes a rough surface, we call it diffused what now? Reflection. So this now takes us to what we call types of reflection. So we have the types of reflection. We won't waste more time on these types of reflection. That's the second part. So what types of reflection are we have? We have the first one we call regular reflection. Regular reflection. Regular reflection. So this occurs when rays of light are reflected along the same direction when they strike a smooth or polished surface. So it thereby implies that regular reflection is a function of smooth surface. Are you with me now? So how do we define regular reflection? We said regular reflection, this occurs when rays of light are reflected along the same direction. Okay, when they strike a smooth surface, e.g., mirror. Okay, mirror, the plane mirror. So whenever we see what now, rays of light is what we call beam of light. Beam. Okay, collection of rays of light is what we call beam of light. So when these rays of light are reflected along the same direction, when they strike a smooth surface, we have what we call regular reflection. So we have something like this. What is that? Suppose we have a ray of light. This is what now? This is smooth surface. This is smooth surface. Okay, we now have the rays like this. This one coming in, this one coming in, this one coming in. So after they strike the surface, okay, once rays of light strike the surface, they must be what now reflected. So this one like this one like this one like this. You see that? They are reflected along the same direction. Along the same direction when they strike a smooth surface. So this plane must be smooth. It must be smooth. Smooth or what we call polished surface. Smooth or what we call polished what? Surface. So this is what we call what now? Irregular reflection. Then second type of reflection is what we call irregular reflection. We can call it irregular, we can call it scattered, or we call it what now? Diffuse. So that second type of reflection has three names. Either we call it irregular, we call it what now? Diffused, or we call it scattered what? Reflection. Have you taken this one down? So I'm just looking at this. These are map, a road map. So I'm looking this one off. So I'll be cleaning what I've explained here. Are you with me? So let's do the second one. Second type of reflection is what we call irregular reflection. Irregular reflection. Irregular reflection. So we have this number 2. Irregular reflection. We call it irregular, or we call it diffused, or we call it scattered what? Reflection. Scattered reflection. So this occurs, okay, when rays of light are reflected along different directions when they strike a rough surface. So the first one, regular, is a function of smooth surface. This one, irregular, is a function of rough surface. So this occurs when rays of light are reflected along different directions when they strike a rough surface. So e.g. wall, okay, or paper. These are what now? These are rough surfaces, okay? So when we have what? Rays of light, when they are being reflected along different directions, when they strike what? A rough surface, we have irregular reflection, or we can call it diffuse reflection, or we call it what now? Scattered reflection. So we are done with this. The first one, we are done with this. This is what now? Type of what? Reflection. So look at this diagram. So this is a rough surface. This surface is what now? Is rough surface. Okay. We now have this rays of light coming here as incident. So if they have to be reflected, so I will go like this. This one can go like this. This one can go like this. Along what now? Different what? Direction. Okay? Different direction. So when they strike what? A rough surface, we have what we call irregular reflection. So we won't waste much time on definition and type. So this is where the work starts. Geometry of what now? Of plane mirror. Please, I want us to pay maximum attention to this, because I'm going to explain some things, some concepts that has never been taught to us in school. When I was in school too, I missed the concept. So please, I don't want us to miss the concept, which are very important. You see questions on them, okay, in the exam, both in JAM, WAEC, and even JUPEB, the A-level exam. Are you with me? So let us go. Geometry of plane mirror. That is the third part. geometry of plane mirror. So we have this geometry of plane mirror, geometry of plane mirror, of plane mirror. Now, suppose I have this like this. This is the plane mirror. These are plane mirror. Are you with me? The ray that strikes the surface of the mirror is what we call incident ray. So we are going to be discussing this under geometry of plane mirror. The first one, we talk about what now? Incident ray. Incident ray. We shall talk about what now? Reflected ray. Reflected ray. After that, we'll talk about what? Our normal. After our normal, we'll talk about what now? The angle of incidence. Angle of incidence. Okay? Then after that, we'll talk about what now? Angle of reflection. Angle of reflection. Then after that, we discuss glancing angle. Glancing angle. Glancing angle. And the last one we discuss what we call angle of deviation. Angle of deviation. Angle of deviation. Under this word now, the mirror. So the ray that strikes the surface of the mirror is what we call incident ray. That ray that hits or strikes the surface of the mirror. This is surface of the mirror. This is surface of the mirror. Surface of the mirror. Okay, so the ray that strikes the surface of the mirror is what we call incident ray. Are you with me now? So that ray that leaves the surface of the mirror is what we call reflected ray. So this incident is coming in. The reflected what now? Going out. So we have to like this. Please pay attention. Pay maximum attention. So this is our incident ray. These are what now? Reflected ray. Arrow will indicate direction. So I must put arrow here, showing that this ray is what? Going in. And I will put arrow here, showing that what now? This ray is going what? Out. This is what we call the incident ray. Incident ray, because it's the ray that strikes or hits the surface of the mirror. Then the ray, this one is a reflected ray. Reflected ray. It is the ray that leaves the surface of the mirror. Okay? Now, between the incident ray and the reflected ray, what we call our normal. Normal is just an imaginary line, okay, that makes the incident ray at the point of incidence. The point where this incident ray, okay, strikes the surface of the mirror is what we call point of incidence. Is it okay in this place? Point of incidence. Point of incidence. Okay? So if the answer is what is point of incidence? The point of incidence is the point where this incident ray strikes the surface of the mirror. Where is it? This point. Are you with me now? It is called the point of incidence because it's the point where the incident ray strikes the surface of the mirror. So between the incident ray and the reflected ray, we now have our normal. We have our normal like this. We have our normal. So this line is what we call the normal. Normal is an imaginary line. Okay, between the what now? The incident ray and the reflected ray. It is drawn perpendicular to the surface of the mirror. So it implies that it is forming angle of what now? 90. Are you with me now? It is drawn perpendicular with the surface of the what now? Mirror. So this place is what now? Angle of 90. Here, angle of 90. Here, angle of what now? 90 degrees. Alright, so we are done with this. We are done with this. What is the angle of incidence? We use I degrees to represent angle of incidence. We use R degrees to represent what now? Angle of reflection. We use G degrees to represent glancing angle. We use D degrees to represent what now? Angle of deviation. So let us go class. The angle between the incident ray and the normal is what we call angle of incidence. Here, angle of incidence. Angle between the normal and the incident ray is our angle of what now? Incidence. Okay? The angle between the normal and the reflected ray is what we call angle of reflection. Angle between the normal, this is our normal class, it's our normal. Normal. So angle between the what now? The normal and the incident ray is angle of incidence. Angle between the normal and the reflected ray is what we call angle of reflection. And angle between either the incident ray with the surface of the mirror or reflected ray with the surface of the mirror is what we call glancing angle. So this place is G degrees. G what? Degrees. Ayika. This glancing angle is the angle that is found either between the incident ray and the surface of the mirror, okay, or the reflected ray and the surface of the what now? Mirror. We call it what now? Glancing angle. Are you with me? So you see that what? Our I plus G give us what now? 90 degrees. Incident angle of incidence plus glancing angle give us what now? 90 degrees. Similarly, angle of reflection plus glancing angle give us 90. Because coming to that, give us 90 degrees. Okay, so let us just finish what will have the effect? What is the last one? Angle of deviation. Good. Now, this ray, we assume this ray is supposed to be going like this. Are you with me? Supposed to be going like this. It now bends to this place. So from here to here is what we call angle of what now? Deviation. Take note. Angle of deviation. What is angle of deviation? Angle of deviation is the angle between the original direction of a ray of light with the final direction. Angle of deviation is the angle between, see, look at this, don't mix everything up. It means this ray is supposed to be traveling like this. Okay? It's supposed to be traveling like this. So what happens to it? It now bends this place. This is the final direction. This is the initial direction. So the angle between the original direction of a ray of light and the final direction is what we call angle of deviation. Then from geometry, if I have something like this Z, okay, if this angle is what now? Is X. This angle too will be equal to what now? X. What's the reason? They are all vertically opposite angles. So vertically opposite angles will form what now? S what? S format. Are you with me now? So what happens here? So it means I can see something like this here now. So this is like this. This one and this one forms what now? So I can say this place and this place are equal. So I can put my G here, G degrees. Are you with me? I'm getting to somewhere. You see. Now look at this. We said angle of deviation. Let me give you angle of deviation. Or should I give all the what now? Angles? Should I give all the angles? Should I give the division of all the angles? So angle of deviation we said is angle. Angle of deviation, angle of deviation is the angle between the original direction of the ray of light, and the final direction. And this angle is always twice the glancing angle. You can see the diagram. That was the reason why I had to put this diagram down. This D covers from here to here. And we see 2G here. So we can say our D is G plus G. This angle, it is always twice the glancing angle. Always twice the glancing what now? And so, I'm saying what's glancing angle? That glancing angle is the angle formed between incident ray, surface of the mirror, or reflected ray, surface of the mirror. Are you with me? That's what we call glancing angle. So from here, we want to get something that's very powerful. I can say my equation 1. Geometry of plane mirror now. Geometry of plane mirror. That's where we are. The geometry of plane mirror. What's the first thing? I can say my I plus my G is 90 degrees. Geometry. From geometry, you have this. My I plus my G equals to what now? 90. I call this equation what? Equation 1. Is it not very obvious? It's very obvious. This base is 90. Everything here is 90. So my I plus my G is 90 degrees. Also, we know that our what now? Our angle of deviation is twice glancing angle. So from here, we have our d to be equal to what now? 2g. Because this is equation what now? Equation 2. Now, from equation 1, what is our g? G will be equal to what now? 90 minus I. From equation 1, just follow me class. From equation 1, you get everything. Equation 1, we have our g to be equal to what now? 90 minus what? Minus I degrees. I call this equation what now? Equation 3. Are you following me? So, anywhere I see g in equation 2, I'll now put what now? 90 minus what now? 90 minus I. I want to give us the formula that connects angle of deviation and angle of incidence. It's very important. We're going to see questions there. So, what is that formula? Let's say substitute. Put g to be equal to 90 minus I in equation. Which equation? Equation 2. So this says for every d, I must have 2 what now? 2g. So here, 90 minus I. So it means our d will be equal to 2 brackets 90 minus what? Minus I. Equation what now? Equation 4. So from here, open this bracket, our d will be equal to 2 times 90, 180. 2 times I minus 2I. So this is the formula that connects angle of deviation with angle of incidence. We call this equation 5. This formula is very important. Okay, so from here, we've discussed the geometry of what now? Of plane mirror. We said incident ray is the ray that strikes the surface of the mirror. Reflected ray, just in the car. Reflected ray is the ray that leaves the surface of the mirror. Normal is an imaginary line drawn perpendicular with the surface of the mirror. Anything that is perpendicular will form angle of what now? 90. Alright? We said the angle of incidence is the angle between the normal and the incident ray. We said the angle of reflection. Angle of reflection is the angle between the normal and the reflected ray. We said glancing angle is the angle that is either formed between the incident ray and the surface of the mirror, or reflected ray and the surface of the mirror. Are you with me? We now say what now? Angle of deviation. Angle of deviation is the angle formed between what now? Original direction of the ray of light and the final what now? Direction. Have said our angle of deviation is always twice glancing. It's a fact, always twice glancing. And I showed how this one come into what now? Into being. Look at this. Particular opposite terms are what now? Are equal. G plus G equals 2G. And D equals to what now? 2G. So the next one we call loss of what now? Loss of reflection. Loss of reflection. We have 2 laws of reflection class. We have 2 laws of reflection. The first one, I'll write the laws here. I'll now solve question. Are you with me? I'll solve question based on what we've done so far. So let us write the laws here. I don't want us to meet out this one. It's not the mirror. Nobody makes this formed by mirror. Okay, no matter. So let us go. So I won't miss anything here. What's the first law? So let's write loss of reflection. Loss of reflection. Loss of reflection. First law says that the incident ray, the reflected ray, everything, and the normal, at the point of incidence, all lie on the same plane. That's the first law. First law says that what now? The incident ray, the reflected ray, and the normal at the point of incidence. You know what the point of incidence is now? That's the point where the what? Incident ray strikes the surface of the mirror. That's what we call point of what now? Incidence. So you know that says the incident ray, the reflected ray, and the normal at the point of that incident, they all lie on the same what now? Same place. This is what we call the first law of reflection. Second law says that what? Second law of reflection. Second law says that. Second law says that the angle of incidence, the angle of incidence, the angle of incidence is equal to the angle of reflection. Please let us confirm. This one is okay like this. Is it okay like this? So angle of incidence is equal to the angle of what? Reflection. So let us get a formula for this. It means our I degrees is equal to what now? R degrees. I call this equation what now? 6. Equation 6. Equation 6. From second law of reflection, angle of incidence is equal to what now? Angle of reflection. I equals to what now? R. So it got very clear that equation 5 can become 180 minus 2R. Since we said our I is what now? Is R. Equation 5 becomes okay. Equation 5 becomes okay. D is equal to what now? 180 minus 2R. I that this one. Since we said our what? Our I is equal to what? Our R. So I can change this I to R because they are the same thing. Okay? Angle of incidence is equal to angle of reflection. Class. The next question will now be, guy, you are just saying this. Just let us solve questions. Are you with me now? Let us solve questions. So to show all the things that we've done before we move on to the next what? Next one. So let's take the first question. This is 2010 over 27. Lego question. So I will take Lego question. I will solve my question. I will solve JAM question. JAM, they love lifting questions sometimes from what? Why and what now? And Lego. So I will take Lego first, take my question before we solve what? JAM question. Okay, so let's go. 2010 over 27. Neko question. Neko question. So let me mark this one up. Let me mark this one up. Alright, so God says a ray of light, a ray of light, a ray of light, a ray of light is incident on a plane mirror, on a plane mirror, on a plane mirror, such that the angle of reflection, the angle of reflection is 25 degrees. Now said, what is the angle of deviation of the ray after reflection from the mirror? What is the angle of deviation? What is the angle? Angle of deviation, okay, of the ray after reflection from the mirror. After reflection from the mirror. So this is the question. So we have options A, 25 degrees, option B, 50 degrees, option C, 65 degrees, option D, 115 degrees, option E, 130 degrees. Now, what's the formula? What is the formula that connects angle of deviation with what now? Angle of reflection. Because in the question, we are given angle of reflection. We have to find what now? Angle of deviation. That? So, what will I do? I will look for the formula that connects angle of deviation with what now? Angle of reflection. So, we have from our D, okay, is equal to what now? 180 minus 2R. It's as simple as that. I just substitute. 180 minus 2 brackets. What are angle of reflection? 25. Okay? So, now be 180 minus what? 50. Which equals what now? 130 degrees. So the answer to that question is what? 130 degrees. The first one is the formula that connects what now? Angle of incidence with angle of what? Angle of deviation. Next one is the one that connects what now? Angle of reflection with angle of deviation, which is the one that we just solved now. This is the next question. 2010 This question 26. Let me confirm. Is question 27. 27. This is never question. Okay, that's the first one. First question. So let's go to the second question. The more question we solve, the more we get used to this. A ray of light strikes a plane mirror and a glancing angle. See that glancing angle. Okay, glancing angle. These are the things that we miss while in secondary school. Glancing angle. We miss glancing angle. I won't lie to you. We miss glancing angle. Okay, but here we are seeing glancing angle. And I explain glancing angle to you. Please don't miss any question under glancing angle. Okay, don't miss any question under angle of deviation. They are very interesting. That's why I have to give you the formula first. And I showed you how I got the word now, the formula. So we have question 2, next question 2006 number 28. 2006 number 28. You have to know. 2006 number 28. 2006 number 28. Let's go. 2006 28 next question. It says a ray of light, a ray of light, a ray of light, a ray of light strikes a plane mirror, a plane mirror, a plane mirror at a glancing angle, at a glancing angle, at a glancing angle, glancing angle of 55 degrees. Calculate the angle between the incident and the reflected rays. Calculate the angle between the incident ray and incident and reflected ray. Incident and reflected rays. Incident and reflected what? Rays. We have the options A, 35 degrees, B, 55 degrees, C, 70 degrees, D, 110 degrees, E, 140 degrees. Alright, now class. Some questions in physics will require us to draw diagram. Okay, just to show the input of the question and to get the output of the question, where the question is going. So in this question, I want us to draw a diagram, okay, for clarity. So here, we have our mirror here. Let's get everything now. We have our mirror here. These are what now? Our normal. Is that not? A ray of light strikes a plane mirror and a glancing angle of 55. These are what now? Incident what? Incident ray. This will be 55 now. Glancing angle to be here. Is that not? This will be our what now? Our reflected what? Reflected ray. Isn't it? So from here to here is 90. If this is 55, what in this space? That will be 55 minus, 90 minus what? 55. 90 minus 55. How will you use this space? And this is just what now? 30, 35. So it means our angle of incidence is 35. Then remember, from the second law of reflection, the law says our angle of incidence is equal to angle of reflection. So if this is 35, obviously this is because what now? 35 what now? Degrees. Angle of incidence, angle of what now? Reflection. This arrow is showing that this one is going in, incident ray. This arrow is showing that this one is coming out, the reflected ray. So what's that the angle between the what now? The incident ray and these are our incident ray. Incident ray. These are reflected ray. Reflected what now? So what's the angle between them? From here to go to here. So angle between incident and reflected because what now? 35 degrees plus 35 degrees, and that goes what now? 70 degrees. The correct answer to this question is 70 degrees. So let's go. Should we solve one question? So yeah, let us now solve jam question. Jam question 2004. Jam question 2004. It says a ray of light makes an angle of 35 degrees with a plane mirror. A ray of light makes an angle of 35 degrees with a plane mirror. What is the angle of reflection? What is the angle of what now? Reflection. So a ray of light, let me write it here. Jam UME, Jam person, 2004. A ray of light makes an angle of 35 degrees with a plane mirror. What's the angle of reflection? A ray of light, a ray of light makes an angle of 35 degrees with a plane mirror. A plane mirror. What is the angle of reflection? What's the angle of reflection? So we have the options. We have 55, 35, 70, 65. 55, 35, 70, 65. This is option A, option B, C, and what now? Option D. All in degrees. All in degrees. So let's go. The ray of light makes an angle of 35 degrees with a plane mirror. This is our plane mirror. This is our plane mirror. So this is the ray of light. It makes an angle of what now? 35 degrees with a plane mirror. With it. It not say this is the normal. Be careful. It says it makes an angle of what now? 35 degrees with a plane mirror with it. So this face is what now? 35 what now? Degrees. And that's our plane angle of reflection. So this face is our angle of incidence. Okay? This face is because of what now? 55 what now? How do you get that? 90 minus 5. But our angle of incidence is because of what now? Angle of reflection. This is our angle of reflection. So if our angle of incidence is 55, yeah, automatically our angle of reflection goes to what now? 55. Because our eye is what now? Our eye from second law of reflection. So we are going to know what now? 55 what? Degrees. For our angle of what? Reflection, which is what now? Which is A. So let's just go to the next one on our agenda. That's what now? Rotation of mirror. Rotation of mirror. Don't joke with this. Don't joke with this. We have plenty of questions here too. On that rotation of what now? Of mirror. Are you listening to that? Let's go. Rotation of mirror. Rotation of mirror. So let's go. Let me wipe this place off. Alright, so let me have a clean board. Go to have a clean board. Clean board. I'm going to a clean subtopic. New subtopic. So let's go, class. Alright, so if you are enjoying this video so far, please just give it a thumbs up, subscribe to the channel, click the red subscribe button, share the video. Okay, it's very important. Click, subscribe, and comment so I will know how far. Okay, so I can know how far. So comment, subscribe, and share the video. Like, give it thumbs up. Alright, so that the YouTube algorithm, okay, can show the videos to more people that need to see something like this. Try those are writing Y, jam, and what now? And prepare A-level of exam. So let us go. Rotation of the mirror. Rotation of the mirror. Rotation of the mirror. Now, whenever a mirror is rotated through an angle, let's assume that that angle is what now? Is theta. It is only the reflected ray that will be affected. Okay, the incident ray will be fixed. So what they will ask us is what now? What is the angle turned by the reflected ray? So that angle turned by the reflected ray is always twice the angle of what now? Rotation. Okay, so we are saying, look at this, look at that. So now you read like this. These are what now? Our plane mirror. These are plane mirror. These are plane mirror. I have this as my normal. I have this as my what now? Incident ray. And I have this as my what now? The reflected ray. Suppose that mirror is at position 1. Position 1. Position what? 1. I now rotate the mirror anti-clockwise in this direction. This direction. Okay? So the mirror, so it means this mirror that was initially here was now rotated to this place. To position what? 2. P2. P2. Anti-clockwise. Anti-clockwise. Since this is rotated what now? Anti-clockwise. Okay? The reflected ray will follow the what now? Direction of rotation. It means this one will move outward to move outward. So the reflected ray will what? Will shift outward. I told you, whenever a mirror is rotated, it is only the reflected ray that is affected. Okay? Because this incident ray will fix. This one is what now? Fixed incident ray. Fixed incident ray. Fixed incident ray. Okay? So when the mirror is rotated through what now? Theta. Look at this. So this from here to here is theta. Okay? Then this is the first what? Reflected ray. First reflected ray. Okay, let's say R1. Reflected ray 1. This is now what now? Reflected ray what now? 2. So an angle will form there. Are you with me? That angle formed between the first reflected ray and the second reflected ray based on rotation of the mirror will be twice the angle between what now? This mirror. So we have 2 times what now? 2 times theta, which is what now? 2 theta. So let me write this one down. Angle turned by the reflected ray. The reflected ray is twice the angle of rotation. Twice the angle of rotation. So whenever a mirror is rotated through theta, angle turned by reflected ray is what now? 2 theta. So if the angle here between this mirror is 40, the angle that the reflected ray will turn will be 2 times what now? 40, which is what now? 80 degrees. So whenever a mirror is rotated through an angle, let's say the angle is theta, the angle turned by the reflected ray or the reflected ray is turned through or the reflected ray is rotated through twice the angle of what now? Rotation. Is it clear? So let us solve question on this before we move on now. Before we move ahead. So we have 1982. Yes, 1982 question from Jam. Before I do that, look at this. Look at this. Here we have angle of incidence. Here we have what now? Angle of what now? Reflection. So they can ask us sometimes that what is now the angle between the incident ray and the reflected ray after rotation? The angle between the incident ray and the reflected ray before rotation is what now? I plus R, which is what now? 2I. Look at this. Suppose I put incident ray here. Okay? I put I1 here, incident ray 1. So the angle between I1 R1 will be equal to I degrees plus R degrees. And recall, we said angle of incidence is equal to angle of reflection. So I can say this one is what now? I degrees plus what now? I degrees. This will give us what now? 2 I degrees. But if I'm considering I1 and R2, angle between I1 and R2 will cover I degrees plus R degrees plus 2 theta. And this is not what? I plus I plus what? 2 theta. This is not what now? 2I plus 2 what? Theta. I can factor 2 out. Factor 2 out, I have what now? I plus what now? Theta. Where I is the angle of incidence and theta is the angle of what? Rotation. So if that's what's now the angle between the incident ray and the reflected ray after rotation? That will be twice I plus theta. Angle of incidence, angle of rotation. So we can pause the video, take the diagram down, write something down before we solve a question. So as you are writing, let me read the question. This is 1982 jam question. Is it okay here? Is it okay here? So jam question. Jam question 1982. Let me draw a diagram for you. Let me draw a diagram for you. So we have this. We have this. We have this. We have this. So we now put something like this here to indicate what now? That the mirror is rotated. You see it? So this place is what? 90 degrees. This place is X. This place is Y. And this place is what now? Is A. Now listen to the question. Just says in the figure below, an incident ray xy, incident ray xy, incident ray xy makes an angle of 15 degrees with a fixed line AY. So it means the angle between this place is 15 degrees. Here says, which is not the surface of the plane mirror. If the mirror is turned as indicated by the arrow through 40 degrees, if the mirror is turned as indicated by the arrow through 40 degrees, it means our sky is 40 degrees. Okay? It means the angle of turn is what? It's 40 degrees. He said the mirror is turned. The mirror is turned through what now? Through the mirror is turned as indicated by the arrow through 40 degrees. What angle will the reflected ray make with AY? What angle will the reflected ray make with AY? So I want to use this page for what now? For the solution. So I won't create this diagram, but I want to make it reference to this one now. This beautiful diagram. My beautiful diagram. Now, it's not beautiful, it's beautiful. So we have this. So let me do the geometry of this one. We have this. We have this. We have this. This is what? It's 15 degrees. Okay? These are what? Y. These are what? Our A. These are our A. This is our X. So the first thing is let us get what? Angle of what now? Angle of reflection. If angle of incidence is 15, what will the angle of reflection? 15 what now? 15 degrees. Because angle of incidence is equal to angle of what? The reflection from the second law of reflection. So what's the next thing? This mirror is now rotated 240 degrees. So this is from here, and now I have the mirror like this. I have the mirror like this. So this is now the mirror. Okay? And now here is what? It's 40 degrees. So what happened? I said whenever a mirror is rotated, the reflection will be affected. To be affected. So this one will shift outward. Why? It will follow the direction of rotation. And the direction is what now? It's going upward. So some will what now? Move outward. Are you with me? So this place now, this is the former incident what? This is former reflected ray. This is the new reflected ray. So this angle here will go to what? 2 times 40. This will go to what now? 80. Like I showed you here. The angle turned by reflected ray is twice the angle of what? Rotation. What's the angle of rotation? 40 degrees. What is 2 times 40? 80 degrees. So now says, what is the angle? Let me see the question. It now says, what angle will the reflected ray make with AY? The reflected ray make with AY, meaning from this space to this space. That angle is what now? Angle obtained after rotation. See the options. We have option A, we have 25 degrees. Option B, we have 40 degrees. Option C, we have 15 degrees. Option D, we have 55 degrees. And option E, we have 95 degrees. The greater side is what now? 15 plus 80, which is what now? 95 degrees. Look at this. Angle between the reflected ray and AY. AY, that's 15 plus 80. But if you say the angle between the what now? Incident ray and reflected, that will be 15 plus 15 plus 80. That's what now? 30 plus 80, which equals what now? 110. 3 plus 80 is 110. But we are being asked to find the angle between the reflected ray and what now? And AY. That is what we have under angle of rotation. Rotation of the mirror. So I'll give you more questions to what now? To look at. The first one, you can solve more questions, we'll just go and check the question up. And please drop the answer in the comment box. So I want that you watch this video. Okay, to confirm that you really watch this video, drop your answer in the what now? Comment box below. Okay, so check this question out. UME 2001. Number 11, under position of the mirror, YA 2006, 2006, number 33. So we won't waste most of our time under what position of the mirror. Then we have YA 2000, YA 2000, question 28, under what now? Position of what now? Of the mirror. So we're going to solve more questions on that. So the next one is what we call Number of images formed by inclined what? Mirrors. Number of images formed by inclined mirrors. Number of images formed by inclined mirrors. So just write the formula out and solve one or two questions. Okay? So that this video will not be too long. Okay? So let's go. Number of images formed by inclined mirrors. Number of images formed by inclined mirror. Inclined mirror. That was just the formula. So whenever you want to find number of images formed by inclined mirrors, number of images formed by inclined mirrors, the formula is n is equal to what now? 360 over theta minus 1. 360 over theta minus 1. So we have our number of images formed. Number of images formed by inclined mirror. N equals to what now? 360 degrees all over theta minus what now? Minus 1. Solve this one first. Let's try to answer from what now? 1. So here n is what? Number of images formed. Then theta is the angle of inclination between the mirror. Angle of inclination. Okay? Between the mirrors. Between the mirrors. That's all. So this is one for what now? Number of images formed. And note, whenever mirrors are placed parallel to one another, the number of images formed is infinite. It's infinite. Meaning that number of images is what now? To infinity. As the case of mirrors in barber shop, Jam always ask that question now. Find the number of images formed by mirrors in a barber shop. The number of images formed is what now? Is infinite. Infinite. Okay? It's infinite. So it means the mirrors are placed what now? They are placed parallel to each other. Anywhere you see mirrors placed parallel to each other, are you with me now? The number of images formed is what now? Infinite. Okay? And that case can be seen in a barber shop. In a barber shop. Take note of that. Barber shop. Okay? Barber shop. Are you with me? So whenever they ask you the question, just pick two things. It's as simple as that. So let's say 2017 number 31, 2017 number 31, and 2018 number 23. 2017 21, 2018 23. So let us go. Let's go. So we have this 2017 31. 2017 31. We have two plane mirrors. Two plane mirrors. Two plane mirrors are inclined at an angle of 20 degrees to each other. Determine the number of images formed when an object is placed between them. Determine the number of images formed. Determine the number of images formed. Number of images formed when an object is placed between them. Is placed between them. We have option A 17, B 18, C 19, D 20. Number of images. What's the formula? Our n equals to what? 360 degrees over what theta and what? Minus 1. So this will be 360 degrees all over. What's the angle between them? 20. 20. Minus what now? Minus 1. So what do I have here? Then we can see 0. Here 1, here what now? It is now 18 as what? That will give us what now? 17. So the correct answer is what now? Just throw the formula and you apply what now? The formula. It's as simple as that. Sometimes they give you number of images. You now have to find what now? The angle of inclination. like this question here, and this question here. So that's good. That's good. You can say 2018, number 13, number 23. Two play mirrors, two play mirrors, two play mirrors are inclined, are inclined, are inclined to each other, to each other, to each other, such that, such that, such that an object placed between them has 11 images. An object, an object placed between them has 11 images. You see it? Now said, determine the angle of inclination. Determine the angle of inclination. Angle of inclination. We have options A 30, B 45, C 60, D 90 what? 90 degrees. So what we're going to do here, we'll apply the formula. Number of images is what? 360 degrees. What about theta? Minus 1. So our n is given as what? 11. Is that not? So we have 11 here. That's what now? 360 degrees. What about theta? Minus 1. Now what is the first thing? Or let right down. So don't make mistake. Let time. So we'll come here. So we have 11 plus 1 equals what? 360 degrees. What about what now? So what do we have here? We have 12. Is that not? So I'm having 12 equals to 360 degrees all over what? All over theta. I cannot cross multiply. I have 12 theta equals to what now? 360 degrees. Other theta will not go to what? Divide by side by what? By 12. So that will go what now? 30. So the number of equations is what now? Is 30 degrees. Okay? So what is that under what? Under number of images formed by what now? By inclining. So we've done so far so good. We've done what now? Definition of what? We've done definition of what now? Of reflection. We've done types of reflection. We've done geometry of plane mirror. That. And we've done what now? Lots of reflection. We've done rotation of a mirror. We've done number of images formed by inclined mirror. The next one is what now? Total angle of deviation between inclined mirror. Total angle of deviation between inclined mirrors. After that, we're now going to do characteristic of what now? Image formed by plane mirror. After that, we go to what now? Uses of plane mirror. As simple as that. So next one, without wasting our time. Without wasting our time. So let us go. Let's go. Let me wipe this one off. Let me wipe this one off. Pay attention to this one too. You see diagrams in jam. Go and check the jam first. You see diagrams there. Total angle of division between inclined mirrors. Okay, so let's try it. Total angle of division. Total angle of deviation between inclined mirrors. Between inclined mirrors. Three inclined mirrors. Three inclined mirrors. Alright, so let us go, class. When I have a mirror like this, please pay attention. I have one mirror like this. This is the first mirror. I call it M1. I have another mirror like this. This is the second mirror. I call it what now? M2. Anytime we have to find total angle of deviation between inclined mirrors, that angle of deviation is always twice the angle between the mirror. It's a fact. So angle of deviation, total angle of division, okay, is always what now? Twice angle between the what? Inclined mirrors. Inclined mirrors. Okay? So that's the formula. Total angle of division is what? Twice angle between what? So look at this mirror. The angle here is what? Is 90. Angle here is 90, isn't it? So means for this mirror now, this diagram, total angle of deviation will be what? 2 times what now? 90, which equals what now? 180 degree. Let us demystify this. Sometimes they won't ask us the total angle of deviation straight. They will ask us to calculate what now? Angle of reflection in the first mirror or angle of reflection in the second mirror. Okay? You can have questions like that. So let me break this thing down so you're able to understand that truly this total angle of reflection is what now? Is 180. So let me have incident ray here. Incident ray to mirror M1. For every incident ray, you must have reflected ray. As is confirmed. As is confirmed. Incident ray. I will have reflected ray. Okay? Now, this is incident ray of mirror M1. This is the reflected ray from mirror M1. You see that this ray is not serving another purpose. What is the purpose? It is serving as what now? Incident ray. This mirror M2. To mirror M1, it is reflected ray. But to mirror M2, it is what now? Incident ray. So for every incident, we must have what now? Reflected ray. So this in this case too. This one will also be what now? Reflected. So here, we are having two reflected rays. Two reflected rays. So here, our normal should be here. Our normal should be here. What I'm trying to prove is that this thing is 180. Is 180. From this mirror, if the mirror is like this, 60 degrees. What is the total angle of deviation? That will just be 2 times 60, which is what now? 120. But this one is inclined at what now? 90 degrees. Angle between this mirror is 90 degrees. That's why it's what now? 180. What's the other formula? Total angle of deviation is twice the angle between what now? Inclined mirrors. So yeah, suppose we put this place to what now? X, our glancing angle. Obviously, this place will be what to what now? Will be X. That glancing angle, X now, should be. If we are assuming that this place is what? Is Y, glancing angle. This place will be what to what now? Y, glancing angle. This ray is supposed to be traveling like this. But it bends to this place to have first division. That between the what now? Original direction of the ray of light with the final direction is what we call angle of division now. Then this ray is supposed to be traveling like this. Like this. What happens? It bends to this place. So we have what now? D what? D2. So total angle of deviation will be D1 plus what? Plus D2. Correct? Let's go. Vertically opposite angles are what now? Are equal. This is equal to what now? X. Vertically opposite angles are what now? Equal. So equals to what now? Y. This our D1 is X plus X. Agreed? So our D1, is X plus X. This is what now? 2X. Our D2 is Y plus Y. This is what now? 2Y. So it is our DT. DT equals to what now? 2X plus what now? 2Y. Factor 2 out. We have S plus what? S plus Y. Now, what is S plus Y? Look at this diagram. I have something like this. 90 is here. This place is X. This is what now? Is Y. What is S plus Y from this diagram? The sum of angles in a triangle is 180. Out of 180, 90 is out. What will be the remaining angle? 90. So when I add S to Y, I must have the remaining 90. So this is what now? Is 90. So it means our S plus Y is what now? 90 degrees. So what is 2 times 90? That is what now? 180. So it therefore implies that total angle of deviation between inclined mirrors is twice the angle formed between the mirrors. If the mirrors are inclined at what now? 80 degrees. Total angle of deviation will be what now? 2 times 80, which is what now? 160. But in this case, it is 90. That was what we have what now? 180 degrees. Okay? But see a question in JAM. Pause the video and write this thing down. Please, I beg you. Write it down. This diagram, you see it in JAM. Check your JAM board, ask question. Even why is it? Plenty. But the first one is this. Okay, I think my mind escaped out. UME 1991. Just look at this. UME 1991. I'll just read the question. I'll read the question. It says, when a plane mirror at which a ray is incident is rotated through an angle theta, the reflected ray will be rotated through, now put A, half theta, B, theta, C, 2 theta, D, 3 what now? See the question. Funny question. Funny question. They said, when a plane mirror at which a ray is incident is rotated through an angle theta, the reflected ray will be rotated through. Class, what's the answer? Correct. 2 theta. That is what now? Rotation of a mirror. Can you see how simple the question is? Jam question. Jam question. Okay. Let us go to this one. 1998. 1998. See that one here. 1998. 1998. 1998. How is it like this? Give us diagram like this. This. See it? They put this one here. This one here. Say this is M2. Yeah, say this is M2. Put M2 here. You put M1 here. You put this in here. They put 30 degrees here. See that? Reflected. After 2 successive reflection class, what we call emergent ray. Okay? Emergent ray is a ray that is obtained after 2 successive reflections. So we have emergent ray. So I can call this one incident, reflected, emergent. Emergent to this mirror, but it's reflected to this one now. Let me recap so I understand what I'm saying. This ray is an emergent ray to mirror M1. Because I'm putting first reflected ray, second reflected ray. So this one is what we call emergent ray to mirror what? M1. But it's reflected ray to mirror M2. Are you with me now? So it's as simple as that. Then I'll say in the figure, below, okay, what is the angle of reflection? What is the angle of reflection? What is the angle of reflection of the ray of light? What is the angle of reflection of the ray of light at mirror M2? At mirror M2. We have A 90, B 60, C 45, and this what now is 30. Please pay close attention to the what now to the solution. Okay, I'll just solve one. You can go and check your package. You see them there plenty. But this one is okay. With this one, you are okay. So look at that one solved. Alright. I'm looking for what now? Reflected ray of light. Angle of reflection of ray of light at mirror M2. So where is the angle of reflection in this case? This is what I'm looking for. This mirror M2 now. Reflected ray of mirror M2. This angle of what? Reflection. So let me put what now? R here. Okay, let me put R2. So to indicate what now? Angle of reflection of what now? Mirror M2. So this one is 30. This one must what now? 30 now. Is that not? Why? Angle of incidence is just what now? Angle of reflection, second law of reflection, isn't it? So this one is 60. What will this place? Everything here is what now? 90. Out of 90, that is gone. What is the remaining? 60. Are you with me? Are you with me, class? This place is 90. This one is 60. This one is 90. What will this place? That what now? 30 what? 30 degrees. Is that not? 30 degrees. This is 30, 60, making what now? 90 here. 30 plus 30 plus this one goes up now, 180. So what that? 30 is the glancing angle here. This one is what now? Glancing angle. So our R is what now? It's 30 degrees. But if you can't solve it like that, look at this. Let me complete this shortly. If this one is what now? This is 30. What will this place? 60 degrees. Because everything is what now? Is 90. Oh, we're not supposed to find this. We have to find this place. Class, rather, we have to find this place. Not this place. This is what our glancing angle. This is our glancing angle. We have to find this place, not this place. So this is our what? Our R2. Angle of reflection of mirror M2. What will be that? Our angle of reflection of mirror M2 just what now? 60. Why? Because angle of incidence is just what now? Angle of the reflection. Are you with me now? We have to find this one, not this one. This is the glancing angle. This is angle of what now? Angle of reflection of mirror M2. This is the angle of incidence of mirror M1. Angle of reflection of mirror M1. Angle of incidence of mirror M2. Angle of reflection of mirror M2. Just pause the video, see the way I explain what now. The diagram. As simple as that. But everything is what? 90. 30. Angle of incidence is angle of reflection. 30, 30. Everything is what now? Is 90. If out of 90, 30 is gone. The value will be what now? 60. This is a triangle. That is a triangle. 60 is here. 90 is here. 60 plus 90 is what now? 150. 180 minus 150 equals what now? 30. If now is 30, this place is what now? Is 90. No, this is what? Normal. Normal means an angle of what now? 90 degrees to what? With the mirror. This place is 30. What will be the minimum one to make 90? That will be 60. Now, angle of incidence here equals to what now? Angle of reflection. So you can see one question from what now? From Y. Check Y. 991 and what? 23. Y 991. Order this. Type Y. 1991. Question 21 now. 23. So let's go to the what now? Characteristics of images formed by what now? By plane mirror. After that, that's what we call the uses of plane mirror. In this case, we're going to write what now? Just short notes. Short notes. I'm done. I'm done. So let's just short notes. Short notes. Short notes. So let's go to the first one. First one is what? Characteristics of images formed by plane mirror. Characteristics of images. Because I always ask question here. Characteristics of image formed by plane mirror. The first one is virtual. Image is what now? Virtual. I'll explain that later. We have two types of what now? Images. We have real image. We have what now? Virtual image. Any image that cannot be seen or cast on the screen is what we call virtual image. Okay? Any image that you can see and cast on the screen, like if you are using a projector, image from projector can be seen on the white what? On the white what now? White cloth. That image is what? It is real. But for virtual, you can't see it on the screen. So any image that cannot be seen on the screen is what now? It is virtual. But any image that can be seen on the screen is what now? It is real. So image formed by a plane mirror is virtual image. It cannot be seen, nor can you cast it on the screen. That's the first one. Number two is upright. Is upright. Or we say it's what now? Erect. What's the meaning? If I take a plane mirror like this, see where I'm standing, and I look at the plane mirror, my head is here, my legs down. I will appear like this. If you look at yourself like this and your head is down and your legs up, something is wrong somewhere. Any image formed by plane mirror is always what now? Erect, upright, standing upright. The way you will appear in the mirror, that is where your image is. Image formed by plane mirror is upright. Are you with me? That's the second one. Number three. If I place an object here, this is the plane mirror. Object here. Ray of light. Try this one. Try this one. Incident. Incident. It will be reflected. 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 Now, if I now produce this one backward, this one place it backward, the image will be here. So this is the mirror. This is the object. Please don't mind my diagram, please. This is the image. The distance from the mirror to the object is called due object distance. This is symbol for use for object distance. U is object distance. Object distance. Get me? Then the image distance from this mirror to this image is V. We call it what now? Image distance. V is what now? Image distance. Image distance. Okay? Now, if this one is 10 meters, okay, this one too must go to what now? 10 meters. So it means the image is the same distance as the object in front. Okay, the image is formed far behind the mirror as the object is in front. Same distance, that's the meaning. Same distance. Are you with me? So our U for a plane mirror, take note. For plane mirror, for plane mirror, our U is equal to our what now? Our V for a plane mirror. Take note of this formula. It's very important. It's very, very important. Image distance is equal to what now? Object distance for a plane mirror. So I can say same distance. That is the second one. Same what now? Same distance. Same distance. Now the fourth one. Now, if you take a plane mirror, everything now, and you look at it like this, with your right hand, take your left hand to hold the mirror. Do as if you want to place something in your mouth like this with your right hand. Now, peep into the mirror, you look as if you are using your left hand to eat. That's what we call lateral inversion. Lateral inversion. So, the turning from what? From side to side of the image of an object when viewed through a plane mirror is what we call lateral. P7 will look like what now? F9. When you place P7 in front of the mirror, it will look like F9. Anything using P7 and F9, nothing is good inside there. P7 and F9, nothing is good. So it is what now? Laterally inverted. Laterally what now? Inverted. Laterally what now? Inverted. And what is lateral inversion? If that's what, that's what now? The turning from side to side of the image of an object when viewed through a plane mirror. You see something like this. You see something like this. I have best like this, best. Okay? When you view best through a plane mirror, it will appear like this. B E S what? S T. So best. Changing from what now? Side to side of the image of an object when viewed through a what now? A plane mirror. Then the next one. Magnification is what now? Is unity. Magnification is unity. Fifth one. Magnification. Magnification is unity. What does it mean? It is our M equals to what now? 1. So this now goes to what we call another thing entirely. What's next? We have linear magnification. We have angular magnification. But in this mirror, we are talking about what now? Linear magnification. What's now the formula for linear magnification? Can I have this one off? So let's go class. Let's go class. Take note because you can also hand good. You're going to be asked question under what now? PO camera. PO camera. We can use this formula without PO camera. Are you with me? So M for magnification. What the formula is? Because of what now? Height of object. No, height of image. Height of image all over height of object. Height of object. That's magnification. It can also be given as what now? Distance of image all over distance of object. Plus same size. Same size too is here. Same size. Same size. So let me put that. Same size. Shall we? If you measure 1.7 meter tall, check yourself through a mirror. You see measure what now? 1.7 meter tall. So same size. So size is what now? Height. So I use what now? HI represent what now? Height of image. I use HO represent what now? Height of object. I use what? V to represent what now? Distance of image. Use what now? U to represent what now? Distance of what? Object. why is this magnification equals to 1? See it now. Let me say our m can be what now? Hi can be what now? H2. Or our m can be what now? V over what now? Over u. And what happens in plane mirror? Image height is same as what now? Object height. You can say hi, the same thing. So just gives what now? 1. What happens in plane mirror? Image distance is same as what now? Object distance. I can equal say what now? V over what over v. Now we go now. 1. Take notes. These are the characteristics of what now? Of the image formed by plane mirror. The first one, it is virtual. Second one, it is upright or erect. Third one, same distance. Fourth one, laterally what? Inverted. Laterally inverted. Magnification is what? Unity. And it has what now? Same size as the object. Then the last but not least is what we call uses of plane. They will ask questions there. You like it, you don't like it, that's it. Uses of plane. First one, looking glass. Here you know now. Looking glass. Looking glass. That's the first one. Don't forget. That one that you place in your what? In your what do you call it? In your bedroom. Is it bedroom? Place it in your bedroom. Even your what now? Your toilet. You see plane mirror there. Looking glass. And the girls too. Our girls. They always go up and down with plane mirror. If you are a girl and you don't have a plane mirror in your bag, you're not a complete what now? Girl. You must have a plane mirror in your bag. It must be there. Plane mirror. What are you using it for? Looking glass. So please, I approach to the girls to the house, please. So the first one uses 1 as looking glass. Looking glass. That's the first one, looking glass. Number 2, in periscope. Periscope. A periscope consists of 2 plane mirrors inclined at an angle of 45 degrees to each other. They will ask you that what's the angle of separation between periscope, the mirrors in periscope? 2 mirrors. The angle is what now? 45 degrees. So take note on this. Periscope consists of what now? 2 plane mirrors. 2 plane mirrors. Angle between them is what now? 45 what now? Degrees. Where do you use periscope? Periscope is used in supermarket to see round corners. So you want to steal. Periscope is what you are. Okay, don't worry, I'm making one. Or are you using now? In supermarket, and so you what now? In submarine. In submarine. Periscope in supermarket and what now? Submarine. So can you use periscope in what now? Submarines. Submarines. And what now? Supermarket. Supermarket. So that's the second what? Now the third one. Kaleidoscope. Kaleidoscope. And all these things look like this. It's visible. Kaleidoscope. This one. A kaleidoscope too consists of what now? 2 plane mirrors. 2 plane mirrors. What are the difference between this one and this one? Angle between them is what now? 60 degrees. For periscope, 45 degrees. For kaleidoscope, 60 degrees. Where do you use kaleidoscope? Kaleidoscope is used in textile industry for color separation pattern. You want to separate colors in clothes, we use kaleidoscope. So it is used in what now? Textile industry. Textile industry. Textile industry for color separation pattern. Color separation what? Pattern. The last, I want to use what we call sextant. 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 Sextant is a navigational instrument which is used to determine the correct altitude of the sun. Okay? If you want to know the correct altitude of the sun, use what now? Sextant. Sextant is the product of what? You see plane mirrors inside sextant. So, plane mirror, that's sextant. So we have what now? Two plane mirrors inside what now? Sextant. So it says what? It's a navigational instrument. This one will be okay like this. Can I see it here? Is what? Is a navigational instrument. Navigational instrument. Instrument used to determine the correct altitude of the sun. If you don't use altitude, you see what now? Height. Can you use what? Height.
if they don't want to use altitude, so that they will miss everything. No, you see ice there. So at this junction, thank you very much for watching this video. I appreciate you all. Please subscribe to this YouTube channel. Okay, share the video, comment in the comment box below. God bless you all for watching. I'll see you in the next video.